In our cooldown for lesson 4.14, we are asked to consider a scenario where we are dealing with elevation and what distance that means a place is from sea level. Now they point out to us here that some places are below sea level, so their elevations are negative. But when we measure distance, we should not get negative numbers. These should all come out positive. So when we go out there and look at these problems, if a town is, or city, is 180 feet above sea level, its distance from sea level is 180 feet. Same thing goes for 12.1. Its distance above sea level is 12.1. Same thing goes for 5.4. If a town is 0 distance from sea level, its elevation must be 0. But then, if my elevation is negative 5.4, in other words, I'm below sea level, my distance from sea level is still 5.4, just downwards. Same thing goes for negative 36 and negative 180. Those distances are still going to come out as positive values. So now, if I want to write an equation for this, this looks pretty similar. This is our absolute value function. So I can write that the distance from sea level for some elevation, so f of e, is just the absolute value of e. In part 3, we are told that two towns have different elevations, but they both have an output of 25. Or in other words, they're both 25 feet from sea level. Well, the easy answer here is that one of the towns must have an elevation of 25 feet. The other answer is that if I have a town with an elevation of negative 25 feet, it is still 25 feet from sea level. Its distance is still 25 feet from sea level. So these are the two possible elevations. Why do they both give the same output? Because both elevations are 25 feet away from sea level. It's just that one is up, one is down. And that wraps up our cooldown for lesson 4.14.